Today we'll be working on lesson 3.8, quadratic regression. So please make sure that you pick up the notes from the front. So the notes is going to be looking like that. This is one of the notes, 3.9 quadratic regression. And the other notes is going to be the calculator steps. Now to put this in our notebook, I know I did this with my 5th, 6th, and 7th period, but my 1st, 2nd, and 3rd, I was not able to do that. So what you need to do is this paper, you need to fold it in a hamburger style and glue that to the right side of your notebook. As for the calculator steps, which is half a sheet, you need to tape the top of it to the left side of your notebook. And I do have my notebook in the front of the room, so you're more than welcome to look at it to give you an idea of how the paper should be glued and taped in your notebook. If you need to pause the video to do this, go ahead and do that. You have a minute. Now, what are the things that you will need to follow along? So you do need to have your supply box on top of the table. Make sure that you have rulers in the supply box. I did check, but it's always good to double check. There is an extra supply box in the room, so if you need extra rulers, you can use that. You do need a calculator, and each team should have a bag of beans. Now, the idea behind this lesson is to have a certain scenario that would give you maybe a quadratic shape. So we're going to graph that. And this scenario is basically layering a circle with one layer of beans. So fill a circle with one layer of beans. And we're going to see, depending on the size of the circle, how many numbers of beans will it take to fill in the circle. So you need your ruler. What you need to do is you need to, I know that the centers are not labeled for you, so take a wild guess, should be somewhere in the center of the circle, and draw the diameter. So basically it's a chord that goes through the center of the circle. Go ahead, draw the diameter for every single circle. You don't have to be 100% accurate as long as you're somewhere in the middle. So as you can see, the diameter does cut our circle in half. And what you need to do is you need to use the ruler to measure the diameter in centimeters, not inches. Now, once you do that, you need to go back to your table and you need to record the measurement that you get in here. So that's the first step, to measure the diameter in centimeters of each of your circles and to record the data in the table. Go ahead, take 2 minutes to do that. Now, I do hope you paused the video and you tried on your own. If you didn't, please do that. Now, I found that the diameter of the first circle in centimeters is 1, of the second is 3, of the third it's 4.5, of the fourth it's 6, and the fifth it's 9.2. So if your numbers are close to mine, that's fine. You don't have to be 100% the same numbers. Now, our second step is to try to layer or fill these circles with one layer of beans and to record the number of beans needed to cover each circle. So I did take a picture. I did this and I took a picture. I used different type of beans, so it took me forever to count the beans. So that's why I got you a bigger type of beans. So as you can see, you have to have one layer of beans. My first circle took 4 beans and so on. So go ahead, take 5 minutes to do that. Fill the circles with beans and count how many beans there are in every single circle and record the data in the table. So take 5 minutes to do that. I want to thank the band for the lovely music in the background. That's awesome, guys. Now, I hope you tried on your own. So for me, the number of beans in the first circle was 5. Remember, I used different type of beans, so my data could be different from yours. So make sure that you record your data in there, number of beans. Now, what are the independent and the dependent variables? Remember that the independent is what? Is it the x or the y? It's the x, and the dependent is the y. So what depends on the other? Does the number of beans depend on the diameter of the circle or the diameter dependent on the number of beans? As you can see, as the circle gets bigger, it's going to contain more beans, right? So yes, number of beans depend on the diameter. So then my x value is going to be the diameter and my y value is going to be the number of beans. Now you have to make a scatter plot with the data that you have. Remember that your data is going to be different from mine. So I'm going to start with you on that. Now, as you can see, let's go back to the table. My x values are always going to be positive and my y values are always going to be positive. So do I need the whole coordinate plane or maybe a part of it? I need a part of it. So what I'm going to do is I'm going to just take the first quadrant where the x and the y values are positive. Okay? Now, I want you to pause the video and try this on your own, but remember that you need a certain scale. So look at your table, and what do you think the scale should be for the circle? Should you be counting by 1, by 5? What do you think? Now, as for the number of beans, do you need to count on the y by 10, by 20, depending on the numbers that you have? Remember to label the two axes and to take a scale and to plot the points and see what's going to happen. So go ahead, pause the video and do that. Now, as you can see, no, you cannot see. Let me make this smaller so you can see. Okay, so I did count on my x-axis every 3 squares to be like 1, 2, and so on, because my highest number was like 9.2, so up to 8, that was good enough for me. And I counted each one to be by 10. Now I labeled my x-axis to be the diameter in centimeters and the y-axis to be my number of beans. And I did plot the points, as you can see. Now I need to connect them, so I'm going to do that with a black pen. Now by looking at the shape, which is not a very good shape, I hope that yours is better than mine. Let me fix it around here. So you can see that my shape does not look like a linear function, right? There's like a certain bend to it, right? It's not like a line. They are not connecting in a line. It's like connecting like a parabola going up. So let's move on with the questions and see what they're asking. Describe the shape of the data points. Now it looks more like a U shape than a line. Do you agree? So now let's see how we can use our calculator to find the regression equation. The regression equation, okay? That best models the data. Did they tell me quadratic or they said regression equation? So let's say I'm not sure. The graph does not give me the accurate shape. So I need to find another way using the calculator. How can I tell whether it's linear or quadratic? So we need to try both linear and quadratic regression to see which one would be a more accurate description. So let's go. So what I want you to do is I want you to go ahead and enter the data in your calculator. And so pause the video. Do you remember how to do that? You go to Stat, Edit. You put your x values in L1, x values in L2. So go ahead, pause the video, do that, and then continue with Now, as you can see, I entered my x values and y values. Now, so remember, you go to Stat, Edit, Enter, and you put x in L1, y in L2. Now, let's say that the graph did not give me a very accurate description, so I need to know from the calculator whether this is a linear or quadratic. So to do that, you need to turn something called diagnostics on. Okay, so you can record the r-square value, because now if I go to Stat and then Calc, if I choose now, let's say I'm confused, I don't know. Should I choose linear? Should I choose quadratic? I don't know. Let me choose linear for a second. And I'm going to press enter until I get my equation. Now, as you can see, my equation is going to give me a line, right? It gives me A and B. Now, if I try to do Stat, Calc, and quadratic, which is number 5, and I'll keep pressing enter until I get my equation, it's also going to give me a certain value. So whether I pick linear or quadratic is going to give me a value. So I need to be able to know which one is the right one. And as you can see, this one gave me ABC. So I need something called the r-square value. And to do that, I need to turn diagnostic on. How do I do that? So remember, these are all written in your calculator steps, but if you need to take notes, please do. So you go to second, 0, which is your catalog, and then you need to go to something called diagnostics on, and that's D. You can scroll down all the way down, or you can go to letter D, Okay, so it's up to you what you want to do. You can go all the way down until you get to D. Okay, so second, 0. To go to D, you can press D. It will take you directly to D, and I need to move on until I reach something called diagnostics on. So keep moving. Okay, there you go. Once you reach that, press enter. It means your diagnostic is on now. Press enter again until you see done. Now once you see that, it means your diagnostics on is turned. So you need to do the steps again to find the regression, the linear and the quadratic one, okay? And record the information over here. And I need to see what R-square for each one is. Okay, so you go to Stat, Calc, number 4, press enter until you get the equation. As you can see now, you're going to see something called R-square. Always round to the nearest hundredth, so it's going to be 0.94. Okay, and my equation, okay, 0.94, and my equation is going to be 22.96. I'm going to round to the nearest hundredth, x plus b. In this case, b is negative, so it's going to be negative 39 or minus 39.41. Now do the same one for the quadratic, so do the same steps. Now you have to press Stat, Calc, then quadratics is number 5. You press enter until you get the equation. And as you can see, the equation has an R-square of 0.99. And the equation is going to be always round to the nearest hundredth, so 2.12x squared, plus the b, which is 1.06x, plus the c, which is 0.47. Now, as you can see, both of them, whether you use linear or quadratic, is going to give you an answer. So for you to decide which one is the better answer, you look at the R-square. Which one is closer to 1? Is the R-square of the quadratic closer to 1, or the R-square of the linear closer to 1? As you can see, this is closer to 1. Then I know then my answer is a quadratic function. It's not a linear function. So there's two ways. You either can use the calculator and look at R-square. The closer R-squared is to 1, then that would give you what shape it is. Or you can look at the graph, because the graph shows that it's more like a U shape, so that's a quadratic equation. So by looking, how does R-square help you determine? R-square tells me that the closer R-square in quadratic is closer to 1. So that helped me decide that this is a quadratic function, okay? It's closer to 1, so that's why I know that. And the shape of the graph is a U shape, so that's why I know it's the best fit is the quadratic fit. Now let's move on to the back page. And over here, they're telling me to predict the diameter, so they need x, of a circle when the y, which is number of beans, is 50, 100, 1000, and so on. So they want x, and the y is given. How do I do that? Now remember that this is a quadratic equation. So you can plug in 50 for y, but then if you plug in, let me go back to the equation. If I plug in 50 for y, I'll have to find x squared and x, and as you can see, this is hard, right, to find what x is. So there should be another way to do that. And the other way is basically to go to y equals, and you can type the equation in y1, the one that you just got, which is 2.12x squared plus 1.06x plus 0.47. And in y2, you put 50 beans. So let's do that. I'm going to put 2.12. So go ahead, do that. I'm going to pause the video. So as you can see, I put my equation y1 in the quadratic in y1 and 50, which is the number that they want in y2, and I graph them. Now you may need to fix your window to be able to see the 50. So that's my quadratic. As you can see, it is a quadratic function. And as you can see, I cannot see the y because it's 50. It's way higher than the y maximum I have. So I'm going to go down and fix my window. Instead of 10, I'm going to put 70. And I'm going to graph it. Now, I will not be able to finish the video here, so there will be another video for you to play.